Today's presenters are Neil Boudreau from Massachusetts DOT and Martha Capitano from Federal Highway Administration from the Office of Operations. Just a quick overview of today's topics. We'll start with introduction of the Smarter Work Zone implementation team, as well as the Smarter Work Zone initiative and need. In the next segment, we will talk about 2 Smarter Work Zones initiatives and practices, technologies in more detail. We will discuss examples, case studies, and after each segment, we will have a question and answer session. The implementation team consists of staff from Federal Highway Headquarters Office, Resource Center, and division staff. We also have representatives, We also have representatives from state DOTs, as well as subject matter experts, and we have 2 contractors providing us support in this effort. The goal of this EDC initiative is to raise the bar in regards to how transportation agencies handle work zone operations. So what are smarter work zones? Smarter work zones are innovative strategies, policies, practices, and tools to enhance work zone operations regarding safety and mobility. In order to understand the need for smarter work zones, it is important to understand the scope of the work zone mobility and safety problem. Here are some statistics. In regards to safety, during 2012, we had 32,000 injuries and 609 traffic-related fatalities. In the case of mobility, work zones results in approximately 20% of non-recurring delay and 10% of all congestions. This results in National Highway System capacity loss of approximately 180 million vehicles per day and an annual fuel loss of over $700 million. As you can see, there is a significant work zone impacts, and therefore the need for smarter work zones becomes very important. So we have identified 2 initiatives. We have the project coordination and the technology application. We will discuss this in more detail after the introduction segment. We're currently working on an implementation plan, and right now we are asking you to provide feedback. We have been doing 6 summits. This will be our 6th summit. We have 1 more summit, and we need your help to understand what are your needs, what tools we can develop to help you implement the Smarter Work Zone initiatives in your state. Our plan will establish goals for specified numbers of state DOTs to adopt activities under the identified activity initiatives that I mentioned earlier. And the plan, again, is to have an implementation plan by January 2015. Federal Highway staff from Headquarters Office, Resource Centers, and division staff will be providing technical assistance to the state DOTs to overcome barriers and any obstacles during the implementation of these initiatives. The support may include pamphlets, workshops, webinars, peer-to-peer exchanges. And funding, as you heard yesterday during the preliminary session, there's the STIC program, the AID demonstration program, and the MAP 21 program. All the information discussed yesterday and today, it's in your flash drive, so if you need any more information about these funding sources, please go here or let me know later after the presentation if you have specific questions regarding funding. Before we move on into describing our Smarter Work Zone initiatives, do you have any questions or comments? No? Okay. So let's start with the first initiative under the Smarter Work Zone initiative. We need to understand that transportation system is a network, and road work at one location impacts operations at other locations. So our project coordination is a coordination within a single project and or among multiple projects within a corridor, network, a region, or possibly across agency jurisdictions. Lack of coordination means many road projects close together, street cuts on recently paved roads, resulting in reduced pavement quality, significant impacts to road users, and increased agency user costs. You know that sometimes, for example, downtown, you will have a transportation agency that will repave the road for 2 or 3 miles. And 2 months later, the utility company comes and cuts the road because all the utilities have to go underground. Well, for the driver, the common driver, they don't understand that, oh, transportation agency was doing this job and now the utility company came back. For them, it's the transportation agency's fault. And you're gonna get phone calls, not because you did a very good job in the first place on the resurfacing project, you'll get several phone calls about, oh, now I have a pothole, or now I have a bump, and how are you using my tax money? So a coordination between projects and between utility agencies can help overcome these impacts and frustration. And we'll share with you what other agencies, because you're not alone in this situation, what other agencies have done to improve their work zone coordination or project coordination with other stakeholders. The City of Baltimore provides real-time information on infrastructure projects across the city via web-based system accessible to all of the stakeholder groups, and each project is mapped via GIS data points. Before they had this project, they had a meeting with all the city staff, gas companies and water companies, and found out that 90% of the roadway cuts were being conducted due to requests from the local gas and water companies. Since then, they have tried to coordinate these events, and during the first year of the implementation of this system, they reported a cost savings of between $350,000 to $500,000. So you can see a coordination not only can save you money, but also retain the quality of your pavement. In Washington, D.C., DDOT has a project management system that tracks and analyzes the cumulative impacts of all work zone projects by the DOT, the developer, and utilities for a moving 5-year period. The system allows them for early identification of project conflicts and impacts, and it gives them a greater ability to reduce and manage traffic disruptions for road work. This is an example from Oregon DOT. They were going to repair and replace hundreds of bridge structures, and they developed a quarter-level TMP transportation management plan to minimize traffic and freight impacts. It's a better picture of what we showed earlier. Washington State has a collaborative multi-agency construction traffic planning effort focused on communication and coordination amongst projects and agencies in the states. These coordination efforts include short-term, mid-term, and long-term information sharing supported by tools developed by the Washington DOT. There is a project coordination tool available, and it's called the Work Zone Implementation Strategies Estimators, also known as the WISE tool. It's a product of the Sharp 2 R11 project, and it proactively reduces work zone impacts. And it includes 2 modules: the planning module, the optimized sequencing of renewable projects that feeds into the operations module, using Dynasty as a platform to evaluate impacts for individual strategies at project level. The target audience is planners and program managers in moderate and large MPOs with an active renewal program. This tool helps bridge that gap between the planning, the MPO, and the design and construction offices. Has the ability to analyze demand and duration-based strategies. Information about that tool is now available in documentation and a user guide at TRB. We have conducted 2 validation sites, one in Iowa and one in Arizona. There are 2 pilot sites, one in Florida and one in Massachusetts. And we will, in the SHARP 2, we'll be providing additional training and resources in the springtime. These are just some snapshots of what the tool looks like. And some states, what they have done is if you have 3 or 4 projects that you know that you're going to work on that particular corridor, the tool will help you identify which project should go first based on the information that you enter in the tool. So that's why, again, it's important for the planning office to work closely with the construction office, and this can be a good tool to basically have those 2 offices work together. Because sometimes, and that's the idea behind this initiative, is to coordinate more. Everybody is coordinating, but when you hear about the coordination, sometimes it goes in silos. The design office is working something, the construction office is working sometimes, but we don't tend to talk. The same will happen with the utilities, like we mentioned earlier. Sometimes, perhaps, when you have that project in the work zone, think about the impacts for traffic incident management. Think about how the emergency responders are going to get there in case of an incident. Coordinating with other stakeholders as well. And now Neil is going to go over some barriers and challenges that we have identified under this project coordination and share with you a case study from Michigan DOT. Go this way.
Sorry. Good morning, everyone. Thank you, Martha. So you saw a couple examples, and then I'm going to go into a case study. But before we do that, I just kind of want to cover some of those barriers. We saw those examples that the state started to work together with their local agencies and even internally. But why don't more people do it? And it's kind of a case of every section or every department or every agency, utility, whatnot, they have their own mission and their own priorities, and they always focus on those. They work in, like as Martha said, they work in their silo. And there's no real incentive or motivation to change the way they do things. It's just plain easier just to continue forging forward with your mission. So the concept of project coordination is to break down that barrier of not working together and start the project from the very beginning, with the initial phase is talking to one another. Find out what the utility company is doing. Find out what the municipality is. So, the state DOT might come in and say, all right, we're doing this big project. But knowing up front the impacts from other local projects helps you kind of coordinate and maybe push your schedule off or accelerate another project. So the other option is there's always that resistance to change. People don't want to change, and unless upper management is actually forging, that change in culture, it's not going to happen. The lower level folks are just not going to, on their own, move forward. And you have to have the financial backing as well as the resource backing to make that change. Okay. So I'm going to give you an example of a case study in Michigan DOT on the I-95 corridor. Does this picture look familiar to everyone? Essentially, we've all been there. We've all been in traffic. We've all had the issue with what is going on. There better be an accident up ahead, or there better be some serious construction. Well, this happened to the Michigan State DOT's transportation director. he was stuck in a long queue. And because of that, he came back and decided that things are going to change in their office. So this case study is going to cover that I-94 corridor. And it's going to focus on what they did developing a corridor operations plan, or partnership, excuse me, performance measures that they put in place for dealing with work zone and technology, resources, data, how they use the information that they have to better communicate to the public, some lessons learned and best practices. And they developed a mission, which I'll cover in a second. So before we get too far into the case study, I just want to give you some basic information and put in perspective what I-94 is. It's 275 miles across the southern portion of the state of Michigan. It covers 3 regions in the Michigan DOT, 9 different counties, and 9 transportation service centers. Each one of them, they all had their own mission, you know, their own goals, so it was all working independently. So because of that, you know, the need to try to get these folks to work together, it was evident in the following example. The work zone safety and mobility rule, basically, they instituted a 10-minute delay per project, maximum. It sounds harmless. You know, if you have a project 10 minutes delayed, that's not too bad. However, this corridor at one time in 2010, they had 19 projects going on at once. For 190 minutes, if you were driving, driving a truck, freight, you could have been delayed almost over 3 hours, you know, just traveling across. And it was that particular corridor and that level of delay that got the DOT director that basically said, we need to change the way we do things. So they developed this corridor operations partnership team. And instead of just grabbing members of those 3 regions within Michigan DOT, they actually grabbed experts from around the state, and they brought everyone together to try to forge a collaboration. So instead of just thinking in that silo, they used resources, and that helped them develop that mission. Basically, improve traffic operations system reliability across the corridor. That sounds all well and good, but then how did they put that into practice? So what they started to do in 2011 was look at each of the individual projects that they had and actually use a model to predict what that travel time delay would be. And then they could look at each individual project and see, all right, this project had X number of delay, minutes in delay, this project had, and then sum it all together to find out, to make sure that they weren't going to go too far overboard. And they decided to set a maximum threshold of 40 minutes across the entire corridor. So then they had to see how they could either move a schedule back on a project, accelerate a project, or maybe not even start a project to basically keep that corridor delay down to below the 40 minutes. And this is all based on predicted travel delays. Once they started looking at the travel delays, then they wanted to say, all right, how do we bring this down to user delay costs? And to start that, they wanted to look at recurring and non-recurring congestion. So obviously, recurring congestion is your normal commute periods when you have your traffic level out there. And then when they started to look at it, incidents were something that no matter what they did, whether it was a weather-related event, a work zone, incidents on the roadway were common across all barriers. So they decided to segregate out those 3 categories: normal recurring congestion, work zone congestion, and winter-related. You know, being in Michigan, they have their fair share of snow. And what they found was more than half of the delays that they saw in that corridor were because of winter or work zones. Obviously, they knew that they had to make a change. So knowing now that they have the issue with delays and they were starting to predict what their delays are in work zones, they started to actually measure user cost performances. So they set a goal in 2013 of a maximum user delay of $108 million across the board for all the different projects that they would have going on. And then collecting that data that they have, you know, for that 275-mile corridor, they developed scorecards. So as you can see here, this is a year-to-date scorecard. And this is their goal threshold line here. This is, the green is actually when they were below that delay threshold, you know, as they're tracking across the year. And the red is when they've exceeded it. And then when they start looking on a weekly basis on the different projects that they had going on, this scorecard was on their website. So the public could actually see what was going on. And that forced the change in focus on the operations and construction side, that they didn't want to be held responsible for not delivering that goal. this graphic is actually very complicated, but that scorecard was also on there. That was daily, a weekly summary of all the different projects they had going on. It's hard to read, but it was very transparent, and it actually caused them to change the way they were doing things. Again, that's just summarizing the three colors. This goes back to 2011 data when they were using their predictive models, and this is what they charted out basically the minutes of delay for each of the different projects within the three regions. And something that was unique about the three segments that they created along this corridor, it's 275 miles. The logical choice would be to make breaks in those segments at the regional boundaries. But they didn't want to do that because that didn't work with collaboration. They actually decided at key junction points along the corridor is where they were going to set those boundaries of the segment for measurement. And that forced Region 1 to work with Region 2 and 2 to work with 3, as well as the different counties that made up those areas, so that they were cumulatively working together to address those delays. So they, obviously, it sounds all well and good to start looking at this information, but they needed data, and they needed to start looking at the tools and the technology that they had out on the roadway. So starting with 2011, they started to implement a sizable amount of ITS equipment along the corridor, so that they could actually capture data on a real-time basis. Instead of just using predictive models, they were actually bringing vehicle probe data and sensor data so they knew real-time what was going on. And then they started using that tool to backfeed some of their scorecard charts. So they said, we predicted delay of X number of minutes. This is what we were actually getting out on the roadway. And they're continually reviewing that information and trying to improve their performance. One of the other unique things that they did was the communication. We all know that, you know, if you're going to collaborate, that communication process has to be part of the mix. So they set up maintenance of traffic huddles, weekly meetings where they brought in maintenance, operation, construction, the permit section, who was giving out the private development or the utility company permits. They all got together and they all had discussion on, you know, what projects are coming forward, how can we work together to basically minimize those delays across the region. It actually forced a change in behavior where they would share time. If we had a project where they knew they were actually going to put beams and they were going to have to do a rolling roadblock or they were going to do bridge demo that was going to cause more delay, they would actually borrow from another project. So it really changed the focus of how they did things. And again, it was all driven by the decision from the upper management, from the director who said you need to change. Excuse me. So again, continuing with the communication, like I said, it came from the top. It gave them that support to make that time commitment. You know, obviously to meet and have those weekly meetings, it takes time out of the normal activities. So that was one of the key components that forged this change. So some of the lessons learned, this change in behavior and culture, it's not easy to start off with, you know, but keeping score, putting that scorecard on, basically, it almost forces you to, like, now hold yourself responsible. And everybody wants to work together, to, you know, because they don't want to be that section or that group that's holding the mission back. It was all designed to minimize the work zone delays, and in the end, the benefit is the customer. Those driving on the roadway, that they're not going to see the increased delays out there. And it also changed construction office in the DOT, started to get involved in the design process. They wanted to know early on when projects were being designed what they thought that estimated delay time was, and they would offer suggestions. Well, if you do this or you do this, or we've had experience in this method, you could accelerate the construction and minimize those delays. So it started to bring this into the development process of the project. Michigan started to use Gantt charts so that they could actually schedule out all the different projects and basically kind of fit them like a piece of a puzzle. Is, all right, if we do these 3 projects simultaneously, we're all working in the same basically area, or, you know, we can minimize delays on that, or we don't schedule this project to start until after this one's completed. It went a long way to basically helping them plan out their projects and minimizing delays. They also started using towing incentives, where knowing that they were going to have impacts on the roadway, you know, we said the incidents are a key part of it. If they could get and clear that incident quickly and prevent secondary crashes, that went a long way to keeping those delay times down. They started doing a lot more work during off-peak times. They started adding incentive and disincentive clauses into construction projects, again, so they could get the contractor to kind of accelerate or use different means and methods to get the job done quicker. And finally, it was the ITS equipment that was deployed on the corridor that allowed them to get this data real time and continually to evaluate the conditions going on in that roadway so that they could keep that scorecard. So that was the case study from Michigan DOT. Chris Brooks from Michigan DOT basically provided this information. If there's any questions specifically to that, I know quite a bit about this because from presenting it a few times now, but if there's more questions, you can ask Chris. So what are the overall benefits of project coordination? We heard some examples from the municipalities, Baltimore, Washington, D.C., Washington State, Oregon, and then we just saw the case study from Michigan. I think at the end, it's that greater ability to reduce work zone impacts and disruptions onto the public. You know, by early identification during the project development, if you can schedule out things or plan things out so that you do have this, this coordination, overall it's cost savings, fewer impacts to the public, and you can dynamically adjust that schedule based on knowing what's happening real time on the roadway. Again, the improved communications among the transportation agencies. I can't understate how important that is, because everyone has, as I mentioned in the beginning, they have their own mission. They all want to get their job done because they have a bottom line. They don't want to add cost to the project. But sometimes that coordination between the groups, you actually can show a cost savings, like in the case of Baltimore, where they were saving money after the first year. The public sees it as less disruption on them, less street cuts, better pavement quality, and I think it goes a long way to keeping satisfaction with the public. So with that, Martha's going to come up and cover the goals for our project coordination subject. Yes, sir. Oh, sorry. Okay. Sorry.
So following up on my question, you mentioned you used a $108 million threshold for user delay. I think it was related to user delay cost.
Yep.
How was that number chosen?
That I don't know. I can look at that. I think what they did is they basically, from looking at a 3-year, they were using a rolling 3-year period of data that they were evaluating what the delays were along that corridor. And they basically related it almost like you would do an incentive-disincentive clause, where you basically have a lane, a cost, and what the impact is on the public, whether it's daytime construction, nighttime construction. So I think it was all part of the tool that Michigan State formed. It's the CO3 tool. It takes predicted delays, but I can look into that a little more.
That'd be great. The other, and then what is the cost per user that Michigan uses as a number in evaluating user cost? That would be good information.
Okay.
Thank you.
Okay. Yes, sir.
Thank you. Do you have any idea how the 40 minutes or the 10 minutes per project was calculated? Was it a comparison of delays without construction to after construction, or was there actual delays or the vehicles were stopped for that period of time along that corridor?
So the 10-minute was a function of basically in the work zone safety and mobility policy, they kind of asked states to come up with like a maximum delay threshold of what you would allow for a project. In our state, we have what's called the 12-minute rule. So nobody can be delayed more than 12 minutes at a particular project. Again, it sounds all well and good in isolation, but when you start to put it in practice with the other delays in the system, but it's above and beyond that recurring delay. So it's, if normal traffic, it takes you 30 minutes to get from point A to point B, the maximum it could take is that 40 minutes to get between those 2 points. How they got the 40 minutes was basically that corridor operations partnership team got together and they started looking at basically what they had for information because they would predict the delay for a project, and then what they used to do prior to this was actually have people drive the work zone and actually measure what the actual delay was. So they kind of evaluated what they were actually getting, and I think it was just the group getting together and saying, what is the maximum amount we want to have for this whole quarter, and what did they think they could achieve, basically by looking at all those projects and seeing what that actual real delay was. But there was no formula or anything behind it, at least to my knowledge. That's from everything I've read. So. It's a nice round number.
Okay, thank you.
Just gonna shut this off.
Take it, because now we're going to the questions. Thank you, Neil. As I mentioned earlier, the implementation team has come up with these goals, and again, this is the opportunity for you guys to provide us feedback and any questions that you may have and ideas for our implementation plan. And we understand that this takes time. Any initiative will take time. We cannot expect to have all these initiatives achieved by tomorrow. Therefore, Federal Highway is here to help you during the adoption, development, and implementation of the Smarter Work Zone initiatives. So for now, the goals are, by December 2016, 20 state DOTs have incorporated work zone project coordination strategies into agency documentation and business processes for improving safety and reducing work zone delays. Because everybody's doing some type of a project coordination, we all know that, but do we have a design manual, memorandum of understanding, something documented that can help that person that comes after you to coordinate and continue the legacy of coordinating projects and ensure that we reduce delays and improve our work zone qualities and mobility as well. Because sometimes we all are coordinating and then you move on or you retire and then the new person doesn't know what to do. Therefore, the goal for this initiative is not only to improve the coordination, the project coordination that you're currently doing, but also to make sure that you do have some business processes in place. And we also want, by December 2016, to have at least 5 pilots, 5 state DOTs who would like to try to pilot the Work Zone Impact and Strategy Estimator, also known as the WISE tool. How many states do we have here? 5 volunteers. This is free, so it's one of the easiest initiatives that you can adopt. And again, Federal Highway will not leave you alone, so we will be helping you throughout. These are some of the resources available. As I mentioned earlier, everything is on that flash drive, but also we encourage you to visit our Federal Highway Work Zone Management website as well as the Work Zone Clearinghouse website, because we do have a lot of information that can help you through your work zone management program as well as the Smarter Work Zone initiatives. And now we will hear from you. We would like to know what is your state doing right now regarding to the project coordination initiative, and if you have any questions, comments. Again, we are here to share with you what we have in mind, but we also want to know from you what can we do to make this happen, what tools we need to have out there. We mentioned that we will have workshops, we mentioned that we're going to have webinars, peer exchanges, but we need to know what else we can do to help you establish and develop these initiatives. Anybody? Thank you.
Sorry.
Rob Lamoche, New York State. A couple of years ago in our state, we had a high-level executive in our state government involved in some significant delay on one of our interstate projects. And as a result of that, we instituted what we're calling our Drivers First program, which is really looking at minimizing delay, just like the efforts that were described here, but really kind of stepping up our coordination efforts with local law enforcement, with the MPOs and everybody else to make sure that not only that one project is scheduled accordingly, but how we're managing all the other projects on parallel corridors so that you have alternatives to choose from to get from point A to point B. So as part of that policy, we've designated a person in each of our regional offices called a surface transportation controller, and their role is to review any lane closures or project activities within the region and try to ensure they are as balanced as possible. They will approve any time restrictions on projects, whether it's a capital project or even a maintenance or permit type work. So we're still kind of gearing up. We have some regions in our state that are really good at doing this and some others that are coming along still, but I think a lot of what you talked about we're starting to do in New York anyway, so that's where we are.
Okay. And something that I forgot to mention is that if your state is already doing or what's called the baby steps, you can sign up for this initiative and bring it to the next level. Again, we mentioned about the peer-to-peer program and the workshops and the webinars. So we can help you pair with another state that perhaps is a little bit more advanced than you and can help you sharing their ideas and their projects experience. So think about that. Just don't think that, oh, because I'm already doing it, I'm not going to sign up. Get credit. That's basically what I'm trying to say. Get credit during this initiative that you're working on that, and perhaps we can help you bring it to the next level. Anybody else? Thank you.
In Maine, we don't have a lot of congestion even in our work zones, but that breeds a lot of, we have a low tolerance for congestion in our work zone. So we've implemented what we've called the taming process. It's traffic analysis, management, and evaluation. So all our projects are looked at, whether it's a 1,000 AEDT project up to whatever our highest levels are. And, you know, we've used Synchro to come up with, you know, what is a delay? We picked 5 minutes. If we go over 5 minutes, we've got to do something different out there on a project, whether it's time of day, not working during the peak hours, night work, off-season work, because we have a lot of people that come in to vacation. So we take that all into account, and this summer we did some ground truthing of what the Synchro models were showing us to see if we're getting things right. And what we saw was a lot of variation even just in the people, the flaggers that are working the work zones. And I mean, that causes a lot of problems if you don't have staff that's well-trained to do that. And we just saw, you know, people only letting certain vehicles through, and, you know, they picked a number rather than, you know, clear something out, keep them going, so that reduces delay. So we've got a lot to work on there, and we're taking baby steps, and we've got a long way to go, and we've had some real mess-ups because what we predicted wasn't right. So I'm looking forward to more prediction tools. So I don't know if that WISE Estimator is a tool to do that or whatever, but we are looking for more tools to help us out.
Well, when you said the WISE tool, what exactly are you looking for the WISE tool?
I didn't know if that could help in the calculation of, you know, when we should be looking at, you know, non-peak times or whatever. I'm not sure what that calculates out.
The tool will help you, will give you some strategies, and will help you decide, okay, is it better to work at night or during the day? And if you have 3 or 4 projects and you're not sure which project should go first, it will help you also determine, okay, should I have project 1 and 3 go first, and then number 2 and 4, and they will give you a lot of strategies.
Because we have less problems with projects on a corridor, we have more problems with projects on adjacent corridors, because if you start taking out options for people to escape it, so we try to balance those too, and I don't know if that will give data to help us on things like that. And
Yeah, I think it will be, the tool should help you, but if you don't mind, before you leave today, just give us your contact information and we can follow up after.
all right, I appreciate that. Thanks.
Thank you.
So my name is Jim Pelletier. Again, I'm associated with the Q Bridge Corridor Project, and Cheryl Malerba did a presentation and included some of the efforts that we're doing out there in the corridor. We're currently managing about 140,000 vehicles per day through a stretch of roadway where we're doing about $200 million per year in construction activities. What we found worked well, and it's an investment, a big commitment by the federal government, but we have a program manager that's specifically dedicated with a public info office, and where we do a lot of public outreach. We do regular stakeholder direct contacts. We have Yale New Haven Hospital right there. We do monthly presentations to the public where the public can just come and vent a little bit. But when they're educated to our difficulties, they actually take that message out to their constituents, to their people, their folks, and they pass the message. So what we found to be very successful for us is the extent at which we do public outreach. We have Twitter feeds. So, again, it's a mega project. It's a $2.2 billion. Actually, we just added to that, so we're in close to the $2.5 billion range with some adjacent projects being done. But public outreach is, we've done, I think, 5 traffic shifts in 1 year in a small, a reasonably small stretch of roadway between 91, Route 34, and 95. And if you educate the public, they find another way. And that's what we found really it works well for us. Other thing that ties this whole weekend seminar together, we do a lot of 3D modeling for specific issues. When we did the tub girders, Route 34 over 91, that was a major effort, and we modeled it, and we brought all the contractors in, including the operators themselves, to see how we viewed it, and gave specific limitations and planned it minute by minute. But that helped us tremendously in selling the idea to the public as well. The 3D modeling, we bring the public and we bring the media in, and sometimes they videotape what we're putting up on our screen, and then they put it on TV. And it's worked very well for us, so just a few thoughts on that.
Oh, great, thank you. Any more questions or comments?
Thank you. Related to the previous comment, back to the Michigan case study, I was wondering what they did for public outreach and if we have any information on that. It sounds like since it was a statewide effort, was there a public pledge made by their DOT director? How did they communicate this 40-minute guarantee, so to speak, to the public, and how, I know you showed that they had metrics to measure how they performed. I was wondering what was the public outreach to advertise this campaign?
Yeah. Actually, it is. It's basically on all the information we have on the case study, that was not actually part of it, but it's actually a very good question, because they made the commitment to put the scorecard and put everything basically transparent on their website, but they must have conveyed something to the public about how they were handling this. I'm definitely will go back and try to find out, because I know that's something that we try to do is that same thing. Like you got to have that communication. You got to let the public know what to do, and I think the better job you do at that, like you said, the less complaints you get, and they actually that involvement and the understanding of what you're trying to do out on the roadway helps go a long way to solving the issue with those complaints and the frustrations.
Yeah, I don't know all the details, but because of the magnitude of that project or projects, I'm sure they did a transportation management plan with all 3 components, and outreach, it was definitely one element of that transportation management plan. But we definitely can get back with you and give you more details on that effort. Then we had 2 more questions.
Thanks, Neil. This is really just a suggestion as you think about developing your educational and technical briefings and things. We, at the LTAP Center, we really are looking at applicability of the EDC initiatives for local agencies. And what I would suggest is that if you look at case studies, to try to implement some that really are more of a local, if there are applicabilities for this for maybe some smaller local projects or some, coordination projects between local and DOT. I think that will, because when I look at this, I absolutely see the State Highway DOT's engagement, but I think maybe a little bit of consideration for the locals as you develop the educational aspects might really help them say, there's definitely something in this I can do, even if baby steps. Just a thought in terms of helping us promote that.
Thank you.
I'm just going to quickly respond to that. I think the examples, we have a lot more information in the examples and the write-ups on those, on the local side of what they actually did on that coordination. And I think even on a DOT level, when we're doing a project, obviously if you delay people on a state route, they're going to divert. And they're going to go into those locals. And it's that communication to find out what's going on the local level, because if they're doing a water main project down where we think that diversion is going to happen, we need to coordinate that type of stuff. And I think that tying it into the locals and changing the behavior and how they work together, it's a key focus. So.
Well, I understand the goal of minimizing disruption. One of the things I think is extremely important to do, though, is to maintain the safety of the work zone. And with all the night work and the pressure to keep traffic moving, the reluctance to maybe have an extra lane closure, and especially at night with the amount of impaired driving, speeding, that's something I would hope that is absolutely considered, is to maintain the safety and the integrity of the work zone.
Definitely, that's one of our goals, is to reduce fatalities and injuries. And what we're looking for right now during the whole work zone program management, not only for this initiative, is to improve work zone safety, not only for the drivers, but for the workers, the mobility of those drivers, and taking in consideration constructability, because those three aspects have to go hand in hand. Thank you.
Thank you. Anyone else?
Any more questions? Well, thank you very much. Now we'll move on into our next initiative, technology applications. We're looking to build the capability and accessibility of ITS technology towards a more modern culture of work zone traffic management. So what is technology application, at least for this initiative, is the deployment of the Intelligent Transportation System, ITS, for dynamic management of work zone traffic impacts, such as queue and speed management. I'm sure all of us have seen articles similar to this. And then you say, well, our work zone meets all our standard regulations, our standard drawings. The truck driver was hopefully not speeding. What else can we do to avoid things like that? Well, technology application may be that answer that you're looking for. When we're looking for technology applications, we want to make sure that they are traffic responsive. They incorporate real-time data that provide enhanced information delivery to drivers, increase awareness of changes to traffic conditions such as weather and congestion ahead, enhances compliance with static traffic controls. You don't want to have a portable message sign to replace or basically have the same message that a static sign. You want to have enough information where the driver can react, whether it's reduce speed ahead or be prepared to stop in advance of the work zones. We want the functions to be automated and dynamic. We want the information delivery that does not require special action on the parts of the drivers. Again, you don't want them to be calling 511 or looking at an app. It's looking at that PCMS and warning them in advance that there may be a congestion ahead. Other considerations, we want to make sure that it's locally focused. They should be targeting information to drivers approaching work zones. The technology application should provide a complete solution, not just the sensors or cameras. We want them to all coordinate that information together. So when the sensor perceives that there's congestion ahead or the cameras have seen it, it can go back to a traffic control device such as PCMS or dynamic bore and show and warn the drivers in advance that they may have a reduction in speed or they may have to stop because of the condition ahead. So what are examples of these technology applications? A queue warning system provides a zone of enhanced speed detection that can detect slowing or stop traffic leading up to a merge point or other capacity bottleneck, and relay information upstream to alert drivers to exactly what to expect as they approach a work zone. Another example is the more modern iteration of variable speed limits technology, which employs a series of portable VSL, or variable speed limits units, equipped with speed measurement equipment. Each trailer, so you want to have trailers like this in the work zone and near the work zone. And each trailer detects prevailing speeds and relays this information upstream to the next trailer, which can adjust posted speed limits to match downstream speeds. The harmonization of speed reduce speed differentials approaching work zones with corresponding benefits and safety. Now, we understand that not all the states have a law in place or may not have a law in place to implement this. But during this initiative, if you state wants to find out what other states are doing and perhaps we're in the same situation a year or two ago, we can help you find that state and share with you their knowledge. Now, if you do have a state law that allows you to have VSL signs, make sure that in order for them to be enforceable, they have to be black and white, because black and white means regulatory. If you have those like this, if you have the sign an orange background or a yellow background, that means warning. Another example is the dynamic lane merge. In low volume traffic, the greatest safety concern is high-speed aggressive merging occurring at the merge point. In this case, the system instructs drivers to merge early to avoid unsafe last-minute maneuvers. In higher volume traffic, we want to maximize lane utilization and minimize queues, in which case the system instructs drivers to use both lanes up to the merge point and do an alternating zipper merge at the merge point. In both cases, the direction to drivers is clear and there is no ambiguity over what is the expected behavior. So what are the system components? We need an infrastructure. We need sensors, we need the traffic control devices that are capable of receiving commands and changing their displays automatically, and communication infrastructure for making everything to talk to each other. But not only that, we need a business process. It's like we mentioned earlier with the project coordination. You do have to have some standard drawings, some specifications, some procurement elements that can help you move into the next project. We do know that all the projects are that react differently, but you have to start thinking about how to implement these ITS applications and start working into your contracts and have a specification that can help you during the project. And what we have found is that there are a few states that have implemented different technology applications, but we're not at a national level standardized. Everybody's doing their own thing. We want to, with this initiative, to promote smart work zones, technology application nationwide and creates a standardization. Federal Highway has developed and published the Work Zone Intelligent Transportation System for implementing Work Zone and ITS. This implementation guide will give you steps 1 through 6 on how to implement Work Zone ITS, and also gives you examples of different technologies that are available. This guideline, as well as case studies, are available on our Work Zone Management website. And I believe the link is also in our presentation. So the question is, are we there yet? And not at the national level, as I mentioned earlier. But again, you're not alone, and if you feel like you are working towards implementing a better ITS program in your state, please call us. We will work with you and help you develop and implement this technology in your state. And again, I mentioned this earlier, and I keep repeating it. During this 2 years initiative, it's easier. We will always help you, but because it's part of the EDC, it's easier for us to develop more and more peer exchanges, more workshops, and we're asking you for any other tools that you think that we need for us to help you implement this in your state. And with that, Neil is going to go over the barriers and then a case study from Massachusetts DOT.
Martha. Again, similarly to the last case study, I just want to kind of summarize what are the challenges and the barriers that we're facing. And I think because it's a technology-driven thing, the biggest one is identifying that benefit to cost. There's obviously a cost to put additional ITS infrastructure out on the roadway. And I think it's not well known what the end benefit is until you're actually trying it. You know, yeah, I can spend a lot of money and get information back, but unless that information is good and accurate and stuff like that, then the public doesn't realize what that benefit is. So we need to do a better job of conveying that, you know, what the system costs versus that benefit, so that we can help, you know, whether it's local agencies or state DOTs, understand when to use this equipment. And I think the Federal Highway Implementation Guide is actually getting us to that next step. Those states that have been doing this, you know, now have some experience, but no one's done a good job in terms of tracking what that actual benefit is. And there's really no out of the box. It's not like you're designing a bridge and you know how to do it. You know, it's pretty straightforward. This is different. You have to kind of do the systems engineering and understand what the situation, what you're trying to solve, and what information you're trying to convey to the public, so that you actually do a good job at delivering that. You know, you have procurement challenges. It's not like you can say specifically in a contract, I need this, this, and this. You need to have good specifications so that you get the proper equipment. In the case of the legislative issues, third-party challenges, you know, variable speed limit sounds fantastic. I know in our state we can't do that, but it's clearly something that I would like to do, have that tool in my toolbox to basically try to reduce speeds in the work zone. Right now I have to go out and actually do a full regulation change, you know, sign it to make it officially, to make it responsible. And you got some resistance in the stakeholders. You know, when we first started doing smarter work zone stuff, the state police were asking, well, you know, what is this information? What are you giving back to the public? And, you know, if you're giving travel time or delay time and stuff like that, how is it being calculated? And you don't want people trying to speed through. You know, the worst thing is when you have the speed feedback. You know, you don't want to give that speed threshold up to a certain amount because you obviously want the public to basically adhere to that limit. And even in the contractor community, sometimes they just didn't understand, you're adding all this new equipment to my construction project and it's making my limits, you know, expend further out. I now have to worry about additional things on that contract. It's until they understand what the benefit is, it's kind of hard to sway those changes. So I'm going to give you some information on a case study on a project that we did in Massachusetts this past winter, the Callahan Tunnel Rehabilitation Project. Essentially, this was a perfect example where we used project coordination and then the technology application to basically mitigate the impacts from this project. The Callahan Tunnel carries 30,000 vehicles a day departing downtown Boston, and we decided to go in and just shut that tunnel down to kind of get in and get out in a 72-day period, rather than trying to do stage construction where we would have impacts you know, for much longer period, and it would still probably cause the same level of congestion that we actually had when we just closed the tunnel. This tunnel is a 2-lane facility, and while it only carries 1,200 vehicles in the morning peak, it was that afternoon condition with 2,300 vehicles an hour in those 2 lanes that now we had to disperse amongst other routes that are already over-congested in that PM peak period. So why are we considering a smart work zone? In Massachusetts, we basically use them as a tool in our toolbox to mitigate impacts. The Work Zone Safety and Mobility Rule asks states to start looking at data and operations in that work zone. So now we're using the smart work zone for mobility applications. We want to be able to use real-time information to deliver that back to the public, to help them make route decisions, to try to prevent congestion in areas where we don't want it to be. Safety, as you mentioned, John, before, having real-time information on where that queue is developing and getting feedback, whether it's a queue message, you know, queue ahead 2 miles or something to that effect, you're giving that information back to the public so that they're actually prepared for what's coming forward, and it helps prevent secondary incidents. Also using this technology, you can detect incidents on the roadway. And finally, it's the planning and monitoring. Having real-time data of what's going on in your work zones and your construction, you can continually refine things as you're moving forward. You can use that data for future projects and planning the next time you're on that roadway or a similar type project application. So we felt that the project on the Callahan Tunnel was a perfect opportunity to use this technology. Unlike traditional construction projects where you have, you know, a set detour route, this project was a little unique because we knew we were over-congested in the PM peak area and other parts of the day, and we couldn't just basically post a detour route and walk away from this one. We had to basically set up 3 alternate routes, basically to give options to the public in terms of how they wanted to get, because closing this tunnel was a direct access to Logan Airport, International Airport, as well as the East Boston and points on the North Shore. So using these 3 alternate routes, we had to do some early action items. And one of those was we actually ripped out a long section of a median barrier and realigned through travel lanes so that we could actually provide additional storage for an off-ramp that we knew was now going to become congested because of this change in the traffic patterns. We also went out in 25 intersections. We went out and evaluated the existing conditions and equipment, made equipment changes, and all did retiming plans to progress traffic along, particularly this corridor here, which was pretty much all signals. They weren't even the DOTs. We went in, they will be soon, but we went in there and made those changes because we knew that we had to progress traffic along that corridor. And finally, we also knew that we wanted to use the smart work zone system to basically give that real-time information, help the end user make an informed decision while they're out there. This is just a screenshot from the Callahan Tunnel project in terms of how far we were actually using the smarter work zone technology. This is our coverage area, and in that we had 15 portable camera stations. We had 6 that were camera and message boards combination, and 5 message boards that we pointed out, in addition to all the other ITS infrastructure that we have in the metropolitan Boston area. We were using kind of a combination of all of it to deliver this real-time information. And in this project, it was fed by probe data. Traditionally, we like to have sensors out there, so we're monitoring traffic conditions, getting counts and volume and speeds. This network was too big to actually just use the trailers, so we went with probe vehicle data. And how did we use that data? This is an example of 2 of the delay thresholds that we developed for all the different message boards, because we wanted to pull that data real time analyze what the conditions were, and then deliver a corresponding message back to that message board to help the public understand what the conditions were. So this is two examples. In this case here, we're telling people to use exit 18 when free flow conditions, but once things started getting worse, we're pushing people towards using the Tobin Bridge as an alternate route. This is just a close-up of that. So we had that three-tier system. And basically, it was using travel time, and I'll use free flow in a very loose, knowing that we had some reoccurring congestion in the corridor, our free flow conditions had a lot of float in there. But as we started dropping down to the different delay thresholds, we would deliver a different message. And I'll show you an example of that soon. This is the system dashboard that our operators, because of the magnitude of this project, our Metropolitan District office basically set up like an operation command center. We have our traditional highway operations center where they manage the traffic cameras and the message boards across the rest of the state. And while they were helping with this project, they knew that they couldn't deliver the hands-on that was necessary for this project. So we mobilized the state police and our operations group from that district. And every afternoon, because as I mentioned, the morning wasn't really an issue, they got together and basically were continually monitoring conditions. So in this operation, you can see the red, obviously, the conditions, what was going on. You could look and see what was going on in the camera. So if you had red in an area that you didn't think there should be an issue, you could look at the camera to see what was going on. You could also look at what that message board was saying to make sure that the public was getting that right message. So this is an example of an intersection that was one of our key hotspot locations. This is the River Road, Storrow Drive in Boston. And at this location was one of those places where you had two options. So depending on what was going on in the rest of the system from that data we were collecting, message boards along that route were directing people to either A, go south onto 93 interstate, basically to get over to the Ted Williams Tunnel, or go north and actually go over the Tobin Bridge to get around. So during the afternoon peak when we had volatile traffic conditions, that message may change throughout that evening commute, basically trying to guide the motorists to the best travel route for them. One of the other key things that we did was our vendor helped us develop this video wall where we had, you can see there's a number of, those are all the camera locations, those blue dots. But we were able to share this with the City of Boston, with Massport, which manages Logan Airport, and with the MBTA. Massport runs a lot of shuttles in and out of the Logan Airport area, and by seeing those cameras, they could actually change their routes on those buses to make sure that they were getting passengers to the flights or people to the parking lots. Same thing with the Transit Authority. They wanted to see what was going on in those cameras because they had to manage headways for our Silver Line transit line. And then the City of Boston was particularly interested because taking that link, which left right in downtown Boston, was now going to cause congestion in the city streets, so we were monitoring those conditions. Oops. So what are some of the positive results that we saw through using the Smart Work Zone? Essentially, is using this equipment and delivering information back real time has helped give the public that information to help them make that informed decision, or at least understand what the delays were and what to expect. And from this, we actually got a lot less negative feedback. So in some cases, we actually got some positive feedback based on the fact that they thought it was going to be Armageddon by we're closing this, and things actually ended up working out pretty well. Having that information about stop traffic in the queue warning system, again, it helps prevent those secondary crashes or actually any crashes from occurring by being able to monitor those conditions real time. This is the particular benefit that I like. The construction office, at first, as I mentioned, they didn't like us. You know, oh, what are you doing? You're adding more responsibility. You're adding equipment to my construction project that now I have to worry about. But by us monitoring and managing the traffic for them, they could actually concentrate on the construction activities. And they left the traffic part to us to manage for them. And then finally, sharing that system access and that data real time with your partner agencies. In our case, we had all the groups within Boston. Helps them, you know, in a collaborative effort. They felt that they were part of this project and that they had knowledge of what was going on. And it wasn't just DOT doing our own thing. It was a shared effort. So what does it all cost? This is the big $20,000 question. Essentially, we've done procurements in two different ways. We've done a lump sum procurement for smart work zones, and then we've done per items. We've had costs as little as $125,000 and as much as $950,000. And that $950 is a big number. That was our Fast 14 project, where we basically, over the course of a summer, every weekend we were taking lanes out of an interstate highway, so we had a very expansive system. I think that cost was well worth the project. And then looking at the individual equipment items, this is the ranges that we've been finding so far. And again, it all has to come down to each condition project is different. It's what type of equipment you have, where are you shipping that equipment from, what level of integration with software is necessary, what communication, what data plans. That kind of drives the cost for these systems. But overall, we're finding that the benefit to the public in the appreciation and not getting those negative comments has allowed us to accelerate some construction and take that extra step in trying to get in and get out. So we're happy with the solution. Some lessons learned is you want to make this as a tool in your toolbox. It's not right for every project. You shouldn't be doing this on every project. You need to identify when you're going to get a benefit out of it and when you need to deliver something to the public to help you mitigate your traffic. You want to start planning early on in the project. You know, the whole concept of operations, as you're developing the construction methodology, your means and methods of doing the job, that's when you start to evaluate, you know, how could I use a smart work zone technology application to help me mitigate those impacts. This is probably the best lessons learned that I can point out is make sure you do a good job with your specifications. You want to convey what you're trying to get out of it, what you're looking for information, so that the results, when you're actually getting from the contractor or whoever's bidding the job, you want to get what you're expecting from them. And then finally, use that data that you're collecting. It's nice to collect it and then spit it back out to the field and let the public know what's going on, but actually capture that data so that you can use it for future planning. As you're doing the project the next time, or you're doing a similar type of lane closure, you can say, oh, back when we did this, you know, we were seeing this throughput capacity based on the delay information that we got. So that's the end of our case study and how we kind of use collaboration, cooperation, and technology application to mitigate the impacts of this project. So overall, what are the benefits? We saw a couple of the examples from, as Martha showed, you know, the dynamic lane merge, the variable speed limits, the queue warning system, and then this was a bigger case study project. Overall, I think you start to see giving the drivers real-time information and making them aware of the situation has gone a long way to basically help prevent crashes that we don't want to occur, help get traffic to either use the route that you prescribe to them or at least divert to a route of their choice rather than sitting in that congestion period and wondering what is going on and why am I being delayed. And it's a tool in the toolbox for traffic management. As I mentioned, it's not for every location, but just having this availability of the data helps customer satisfaction. I think that's the key takeaway from this for the public.
Thank you, Neil. So now we'll share with you our goals under this technology application initiative. And again, these goals may be modified as we finalize our implementation plan. And this is a good opportunity to hear from you guys. So our goal will be that by December 2016, 35 state DOTs have implemented business processes for planning, design, procurement, operation, and evaluation of works on ITS, what we call the 5 steps for implementation process. Again, all that information, this is a very good tool to help you to achieve this goal. And or have utilized at least one work zone ITS technology application for dynamic management of work zone impacts such as speed and queue management. Here are some of resources that we have available in our Federal Highway Work Zone Management. There are some NCHRP reports about ITS and work zones as well. And as I mentioned earlier, the National Work Zone Clearinghouse is also a very good tool that can help you implement ITS and work zones in your state. And remember, Federal Highway will always be with you to help you during the development and implementation of the Smarter Work Zone initiative. And now we'll open this session for questions and comments. Thank you.
Just a quick question. You had mentioned 2 states that are moving forward on technology application initiatives, particularly in the areas of speed management. Are they aligning those with increased enforcement capabilities? And because I'm thinking that that would be a kind of a critical aspect for success in those. Like, are they kind of aligning a different initiative to that, but just something that could help support that, particularly in those areas of getting support for speed management?
I know specifically Illinois State DOT and Illinois State Patrol, they're actually the leaders kind of in automated enforcement and using this technology of using those variable speed limits for work zones and then following it up with the actually enforcement. And I know Maryland DOT, I think, is doing it as well. I think across the board, even something that we're doing in our state is we've been doing for the last 3 years now work zone speed enforcement. We're actually, above and beyond having state patrol or state police out there to basically help the work zone operations, we are actually paying to actually have them enforce the driver laws out there and actually pulling that data back and actually seeing, all right, it's costing us X number of dollars to have them out there doing the job, but we're bringing this much money back into the system and actually changing some behavior. You know, that's the key, is you can't just pay it unless you're changing behavior. People are starting to slow down in work zone, and our construction folks absolutely love it because there's a sense they feel a little safer out there. People are slowing down and they're paying attention in the work zone.
Yeah, and you can also use federal funds, if that project is funded with federal funds, to have law enforcement enforce speed in that work zone and be reimbursed by the federal government.
Yeah, our program is actually funded through HSIP. It's one of our strategic highway safety plan initiatives. What else? Steve?
For the smart work zones that you guys put in, did you guys run them or did the vendor run them for you?
So the way that we've been handling it, and I guess it's kind of, is we've been managing. Basically, the vendor will come in and they set them up, they calibrate the system, and then they're responsible for basically maintenance. But the way we've always done it with ours is, in our specification, is we kind of drive what information we want the public to get back. So it's an automated system. It's based on different delay thresholds or a queue threshold. So the system will automatically give that information back. The actual day-to-day management of it has actually been through the traffic, our group in the district traffic offices and our operations folks. And that's really because our operations center is going through the ATMS process. They're going to be developing their ATMS. And right now they're managing like 40 some odd different systems. And they basically said, we can't take on the responsibility for managing another system. Now they have access to our smart work zones and they can see and they can monitor, but they didn't want to be in the business right now of having to manage it. So we're handling within the traffic groups and in our districts.
Any other questions?
Yep.
Thank you.
My company does mostly bridge engineering, and we do a lot of MBIS bridge inspections and a lot of work for contractors. So we're out in the work zones all the time. I'm more concerned with worker safety than anything. Are there any initiatives that are going on that are directly concentrating on worker safety rather than, you know, the travel aspect of it? Like, you know, when you're out there doing the inspections, you just have the orange cones. And, you know, is anybody working on lightweight movable barriers or anything like that that would really make that safer work.
Do you have an answer for that?
I'm not familiar with technology application, particularly other than what we have shared so far, but I do know that under our Federal Highway Works on Safety grants, we are developing guidelines and fact sheets and different trainings to basically train workers or designers who do the work zones to improve work zone safety and mobility.
And I guess there's a couple ways. The technology side is the cue warning thing is helping to try to, when you do have those situations where you have the lane closures, of letting the traveling public know. There are some intrusion alarm systems, electronic systems, where actually, if a vehicle does breach that work zone, it does send an alarm. So that's kind of a technology application. In terms of safety-wise, there are some tools and some products out there that kind of help. That there's things that we've started to test out in Massachusetts. It's a portable rumble strip. Basically, so if you're taking a lane, you obviously want to alert the traffic of what's going on. Use this rumble strip as a means to kind of alert them and get them to slow down when they're entering that work zone. But it also serves to benefit the workers, because if it's late at night and there's not a lot of traffic on the roadway and they're out there and it's dark, somebody hits that rumble strip, there's a vehicle coming, and it kind of helps you get alert. One of the other things is, we're looking at using synchronized lights on our drums for the taper. Basically, it's another tool to help, because, again, when you're in an isolated situation, sometimes the public, whether it's drowsy, it's dark, and they don't see, they see the barrels, and using these lights where basically they're synchronized, they actually it almost looks like an arrow board forcing them over to the next lane. Again, it's not necessarily helping the worker. My philosophy is having a truck-mounted attenuator out there. Anytime there's somebody on the roadway, you want to have that attenuator. Let that get hit and destroyed versus having the workers get hit. And I think you start to see more and more states are trying to do that, and it becomes a resource issue, but I think, what is the price of safety on the work zone? Any other questions?
Any other questions?
Yes, John?
Just a question. Is anything being done with the providers of GPS or the people that develop these apps and that? Is there anything that could be kind of plugged in that there is a zone?
So all I can speak to is what we've done in our state, is that when we do know we're going to have a project and we are going to use the data and stuff like that, is we have a requirement in our specification that any data that's collected in these things comes in an XML feed. So that it goes to our developers page, so that someone can actually use that information and then spit it back to the public. So far, we have not seen anyone grab work zone related data. They're just grabbing our traditional travel time message boards. One of the things that I am working on, and it's going to be a significant cost, so I'm going to apply for one of these grants, is because I have a lot of smart work zones all over the place, and knowing my operations center, it's going to be difficult for them if they have to manage 5 different vendors' software. I'm looking to do a tool that no matter who's the vendor on the road, so long as they give us that information, it's going to come into a centralized processing site, whereas we can create dashboards and things on our website and applications for somebody to get information on work zones by having all that XML data go to one site. So that way there, our operations center and anyone that we want to give the information can see what's going on in those work zones. So before you leave your desk, or if you're like a doctor or a nurse and you work the late shift and you're always stuck in our construction because we do everything at night, you can look on this new system and say, oh, this roadway is got construction and I know the delay is X number of minutes. I can either wait or I can divert and go around. But the Google folks, and their Waze product and stuff that they have, they are taking that data. Anything that they can get, they are using it and conveying it out to the public. I don't know how they grab the information.
They have your
Yeah. Yeah, so they are pulling it, like I said, we try to put any of our work sites, they try to, they're all mapped and stuff, when we can. But that waste product that Google has, it is pulling in free data that they can get from anywhere and conveying it out. And I think that's the future, is those type of applications.
Any other questions or comments? Well, I will give you some homework then. As you know, everybody got a copy of this flash drive. You also have, as part of your handouts, information about the smarter work zones. So please share that with your staff members, other stakeholders, and partner with your local Federal Highway Division office, whether it's the EDC coordinator, the safety, or the operations engineer, to start working towards smarter work zones. So we hope to have that your work zones will be smarter and wiser, because you're going to try that tool, the WISE tool. And if there's no other comments or questions, we thank you all for participating and for the feedback, and we look forward to working with you during the implementation of the Smarter Work Zone initiatives in your states. Thank you.